So, welcome to another episode, or the first foundational episode after installing your software. Before we get into simulation, I would like us to look at some basic or general information. We're introducing Aspen. And we're looking at theoretical foundation and terminology overview. Let me check this. Right, we're looking at the general overview of everything. Yes, everything is okay. So, what is Aspen HYSYS? First of all, it's a process simulation software used in oil and gas industry, chemical and environmental engineering. We use it to design, optimize, simulate processes before, normally when you're trying to learn how to do something or to design an engineering solution, you can either work with trial by error, which entails that you design the solution live, you test it. If it fails, you design, but now you see that the cost increases. But with the help of software such as Aspen HYSYS, you can simulate possible solutions to your engineering problem without spending much. Then you just realize the actual solution, which works after, based on simulation and based on data. So Aspen helps us to design, optimize, simulate processes such as distillation, water treatment, chemical conversions, and so on and so forth. I think here that's not necessary. The key theoretical concepts that you need to understand: we have mass and energy balance, the fundamental laws of energy conservation. And what does the law of energy conservation say? Energy can neither be created nor destroyed. It can be changed from one form to another. And if you look at Albert Einstein's law, E is equal to mc square, when we're talking about mass defect and all of that, you see that mass can be converted to energy and back, so on and so forth. We also need to understand thermodynamics, fluid behavior, solubility, the phases we have: solid, liquid and gas. You need to understand phase behavior, which is thermodynamics. You need to understand reaction engineering, like if you want to convert something to something, you want to convert maybe methane to methanol. How do you do it? What are the reaction conditions and all of that? That's reaction engineering. And then you have to maybe understand separation processes, like if you want to, and it still falls under reaction engineering, if you want to maybe separate two soluble liquids, how do you achieve it, right? And some important terminologies that we need to understand include a component. What is a component? A component is just a chemical substance, e.g. water, sodium chloride, acetic acid, methane, ethane, propane, 1-butol, and so on. You need to understand what the stream is. It's just a flow of material, and all of this will show them in the software. Unit operations: equipment performing a physical or chemical transformation, like a separator, a mixer, a cooler, and we'll look at it. Fluid behavior: a thermodynamic or fluid package, a thermodynamic model that defines how a component behaves, e.g. Penn Robinson's. We have Uniquark, NRTL, and so on and so forth. So before you carry out a simulation, this is a general simulation formula, or what you should be thinking about. The first question you ask is, what do you have? What do you have? The next question is, what is your expected endpoint, or what is the final solution, or what's the final answer that you desire. And the next thing you can ask yourself is, how can you use what you have to get what you're looking for? In an example, you have data, right? And you need to convert that data to maybe understandable information. Now the question is, how are you going to convert that data to maybe that understandable information, like a graph? Then how can you use what you have to get what you want, or what you're looking for? You can use a graph paper, you can use a computer maybe to simulate your data. You can plot graphs manually. So that's using what you have to get what you want. For example, I have about 1,000 pounds per meter cube of water flowing at a low pressure of about 2 bar gram at a temperature of 40 degrees. How can I increase the pressure of this liquid? So that's just an example that we'll be working with in the software. So when you open your software, this is what you have. This is what you have, and we'll be explaining as we're going. Right, still recording. We'll be explaining as we are going. Now, the first thing you have to do when you open your software is you can either open a simulation that you were already working on, or you open a new case. You click on new, you click on create new case. You click on create new case, and here in this new case you have this tab here, up here, all of this. Here you have your home tab, which you can manipulate your component list, method assistant, reactions, and so many other things. Petroleum assay, this is when you're dealing with a particular crude oil, type of crude oil, maybe from a particular block or exploration block. You have your oil manager, convert this, and so on. PVT, pressure, volume, temperature. You have the view panel where you can customize how this looks like. You have the customize where you can convert tables, conceptual designs, and all of that. You have resources where you can seek for help. So the first thing is I have to select my components. Remember, we're working with water, right? Remember the definitions that we gave. We're working with water. This is important data, this is important data, and this is also important data. How can I increase the pressure? The end point is to increase the pressure of this liquid. So here I'll need to select my components. So from here I'll click on add, and then here I'll just search water, then it adds. Now when we have some more complex simulations, we'll see what